Hey guys, Mr. King making a video today about multiplying and dividing powers of 10. I know that my microphone's not great and the air conditioning's in here, so it's kind of loud. I plan on hopefully getting a better microphone, hopefully tomorrow, so in the future maybe my videos will sound a little better. At least that's what I'm hoping for. I'm also using a new software. I've used it before a little bit, called OBS, to do some scene transitions and stuff, so hopefully that works. Hopefully you're seeing the screen right now, multiplying and dividing powers of 10. So we're going to talk about, this is pretty simple, but it's going to be important to us because what we're going to be doing is we're going to be converting. And this is actually one of the most important things I think that we can learn in this class, because it's something that, I'll say the way that we convert may be different than the way you've done it in the past. We're going to be converting using a method called dimensional analysis. And dimensional analysis is really just, it's almost more of a problem-solving skill that can be applied to many different places. It's something I learned how to do in high school from someone who was involved in Science Olympics. And it was super useful because next year you'll take chemistry, and there's a good chance, depending on what you're going to do, you may have to take chemistry in college. And it's a tough class for a lot of kids, but I can tell you that just knowing dimensional analysis, I could almost do all of chemistry without any problems. I got an A in that class. It wasn't that hard for me because I knew how to do this. So so that's where we're heading towards. But first we need to know how to multiply and divide powers of 10 very quickly. Now obviously you have access to a computer, which is fine, but I would like to, or a calculator, which of course is on the computer. I would like to show you the advantages of doing this without a calculator, how fast it is. So I'll give you 5 seconds to see if you can figure the answer here. Correct answer is B. Correct answer is A. Correct answer is C. Now, I was able to do those calculator very quickly because of the nature of the pattern here. So let's see if you can find the pattern here. At this point in the video, you can pause it, take a few moments, see if you can figure out. Probably not too hard to get, but I'm sure you got that. Okay, hopefully you paused it. And you can clearly see that when we multiply powers of 10, the shortcut is we just need to add the exponents, right? So 10 to the 5th times 10 to the 3rd is 10 to the 8th. 5 plus 3 is 8. When you multiply powers of the same base, and we're mostly sticking with powers of 10 because we use a base 10 numerical system, but it works with any, as long as it's the same base, you can multiply powers of the same base, and the way that you do that is you simply add the exponents together. So now see if you can do it. Correct answer is C. Correct answer is 10 to the 100th. So I've got to do a little transition here because I still haven't figured out a good like whiteboard software, but I'm working on it. Okay, so the answer to that number, the answer to that question was 10 to the 100th, right? This number has a name actually. It's called Google, and it's spelled just like you see here. You may say, well, that's not how you spell Google. I know how to spell Google. I use Google all the time, right? Every day you use Google. We're on Google Classroom and whatnot. Well, this is how you spell the number Google. Now, Google, the company, obviously uses a different spelling. Can you figure out why? Copyright. I can copyright a word that I made up, right? Like Google. I can copyright that. I can't copyright a number, right? It's much harder, at least, to defend your copyright of a number and to protect your copyright of a number. So Google, may wonder why they chose that. If you remember in like the old version of Google, and you can still see remnants of it, but like when you would search, right, they would show you all these pages and all the O's, and the word would be results, pages of results. And so, Google wanted to clearly convey, like, hey, if you use us, you're going to get lots and lots and lots of results. Because at one time, Google was not as ubiquitous as it is today, right? So it wasn't everywhere. Google was just another search engine competing with many. And so that was one way that they set themselves apart. But Google is a number that takes a long time to write using standard notation. right? You can write it, right? Just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So there's 20. I would have to do that 5 times to write out Google. So it's 1 with 100 zeros. So again, it's not hard to write. It just takes a little bit of time, probably about a minute, maybe slightly less, to write out the number Google without using scientific notation. But there's another number that's bigger than Google, and that number is called Googleplex. So for that number, that Googleplex is 10 to the Google power. So that would be a 10, and then I would have to write, for the exponent, I would have to write 100 zeros. On and on and on until I get to 100. There's maybe the 99th zero, and there's the 100 zeros. So that's a big number to write in scientific notation. What's interesting about Googleplex is it's actually such a large number that it is impossible to write out without using scientific notation. Okay, and this is where it gets a little abstract, bear with me. So Google is 1 with 100 zeros. You can write 100 zeros, not hard, just takes a little bit of time. Googleplex is 1 with the Google zeros. You cannot write out a Google zeros. That number is so large that it is physically impossible. There's not enough time. The universe has not been around long enough for anybody to even get close to writing a Google zeros. So anyways, this is just and there's one more way you can write Googleplex is like this right here, 10 to the 10 to the 100th power. So you can see that using power notation helps us condense numbers down, and just like scientific notation does as well. All right, moving on. What about dividing? So again, take a moment. You can pause this, hopefully find the pattern. Okay, hopefully you paused. You can see that you can subtract, right? When you divide powers of the same base, you simply subtract the exponents. And order matters, of course. It's always first exponent minus the second one. So in the second case here, 3 minus 4 is -1. And by the way, the multiplication is addition. That works with negative values as well, as we'll eventually use. So simply, when you divide powers of the same base, just subtract the exponents. That's simple. Okay, let's see if we can do these in 5 seconds. Time. D is the correct answer. What about 10 to the 0? You know what that is without typing it into the calculator? You might remember that anything to the 0 power is 1, but that always bothered me a lot. Like when I was a student, I always asked. I did ask my math teacher. I said, okay, anything to the 0 power is 1, but why? Because I thought it should be 0. I thought, well, like 10 to the first, that's like 110. 10 to the second, that's 2 10s. 10 to the third is 3 10s. It's easy. You just multiply them together. So if you have 10 to the 0, it's 0 10s. So it should be 0 is what I thought. But it's not. It's 1. Why is that? Well, it has to do with our base system, right? But it's easily proved why this is 1. We can do it very quickly because we start out with, let's just keep it simple, 10 to the second divided by 10 to the second. Now, using our rules of exponents that we just learned, when we divide powers of 10, we subtract the exponents. So 2 minus 2 would be 0. Of course, 10 squared is 100, so this is really 100 divided by 100. And of course, any number divided by itself is just 1. Therefore, you can see here, 1 is 10 to the 0. So a very fast way we can prove that. And you can we use 10, but you can use any base. So it's easy to see that any base to the 0 power is going to be equal to 1. And there's a quick proof for why that is. Okay, so for today's practice, you're going to have a few problems on Schoology, just kind of like we did before. You can have as many attempts as you want. I think it's pretty straightforward. I don't think there'll be any problems. And again, I would like to emphasize just being able to do this without using a calculator as much as you can, simply because it's just going to make it faster in the future. Because what we're heading towards is being able to, we're kind of moving towards being able to convert using that being able to convert using the powers of 10 and dimensional analysis is where we're going to. So hopefully all this worked. Again, this is a lot of new technology for me. I like it, but it's taking a little bit of time to figure out. So please let me know if you have any questions.